Good morning everybody. Hope you are all healthy and safe at home. So let us begin with today's lecture, section 9.13, surface integrals. So in this lecture what we are going to discuss is about the terminology of the mass which is related to the density mass of a particular surface. So it is just a formula, and we will do a problem related to that in today's lecture. So let's see, what is the mass of a surface. Suppose we are given the density of the surface at any point by rho of x comma y comma z, or mass per unit surface area, that is the density. Then the mass of the surface is given by m is equal to double integral over s rho of x comma y comma z into ds. So the mass is treated actually as the surface integral, which is related to the surface integral, except that instead of the function g we have the density function rho. Okay, so I hope it is clear. This is the formula. It is double integral over s rho of x comma y comma z into ds. Now let's see one example related to that. So we are moving on to the example. The example is, we are asked to find the mass of the surface of the paraboloid z is equal to 1 plus x square plus y square in the first octant for 1 less than equal to z less than equal to 5 if the density at a point P on the surface is directly proportional to its distance from the xy plane. Okay, so how are we going to evaluate the mass? Mass is given by double integral over s density into ds. And what is ds? ds is the differential of surface area, and it is root of 1 plus fx square plus fy square into dA, right? So here we have to identify two terms. One is what is the density, rho, and the other thing is what is f. Okay, the function f is clearly given. Z is equal to f of xy is equal to 1 plus x square plus y square. So the concept of the formula for ds can be easily evaluated. That will be nothing but root of 1 plus what will be the fx with respect to x means it will become 2x, right? 2x square. So it will be 4x square. Similarly, fy will be 2y, and the square will become 4y square. So ds is nothing but root of 1 plus 4x square plus 4y square into dA. And now we have to determine what will be the density, right? We are given that the density is directly proportional to its distance from the xy plane. So if you see in figure 9.13.4, if this is the xy plane, the distance from this plane can be treated as nothing but the z axis, right? Okay, I am at a distance of 5 units from the xy plane, means z is equal to 5. I am at a distance of z at 3 units from the xy plane, means z is equal to 3. So we can consider rho of x, y, z to be equal to k into z. Okay, k is the constant, proportionality constant. So now we know all the terms to determine the mass, so we can determine the mass. Mass will be equal to double integral over s kz ds, which is nothing but k into double integral over the region r. R is the thing which we have projected to the xy plane, into k into z. Instead of z, I am going to replace it by 1 plus x square plus y square into root of 1 plus 4x square plus 4y square into dA. So now we will evaluate this corresponding double integral. So that is we have to evaluate the area over this portion. So how will we do this? As you can see that it will be much easier if we consider the polar coordinates, right? Because here clearly r varies from, this is our circle, and it will be nothing but x square plus y square is equal to 4, and so the radius will be 2. So we can consider it as 0 to 2. R varies from 0 to 2, and we need half of it, right? I mean 1/4 of the circle. So, and the angle is clearly varying from 0 to pi by 2, right? So the limiting value is easy, means the limiting value can be evaluated easily, means it is simple to do in polar coordinates. So we shall convert this into polar coordinates, and correspondingly we will get the mass to be equal to k into integral 0 to pi by 2 integral 0 to 2 1 plus r square into root of 1 plus x square plus y square is equal to r square, right? So 1 plus 4 r square into dA will be nothing but r dr d theta. So we have to evaluate this with respect to r first. So how can we do that? First what we'll do is we'll open this bracket up, so that will be r into root of 1 plus 4 r square plus r into r square is r cube into 1 plus 4 r square whole raised to 1 by 2 into dr d theta. Okay, so the first term, how will we evaluate it? You can evaluate it by the method of substitution, right? You put 1 plus 4 r square is equal to u, so you will get, when we differentiate it, we get 8r into dr is du, so r and r gets cancelled, so we can evaluate it, and the value will become 1 plus 4 r square raised to 3 by 2 whole divided by 12. Okay, you can just do it by yourself and see. So here this is, we are applying method of substitution. Now in the second term we cannot apply the method of substitution because none of the r's will get cancelled out. It will get cancelled, but there will be a remaining term, so we won't be able to evaluate it. So here what we are going to do is we are going to use integration by parts, where our first function will be r cube and the second function is 1 plus 4 r square whole raised to 1 by 2. So how can we do integration by parts? It is nothing but the first function into integral of the second function minus integral of differential of first function into integral of the second function. So we will have to, while evaluating the integral of the second function, the function that is 1 plus 4 r square whole raised to 1 by 2, we'll have to again apply the method of substitution. So correspondingly you will get 1 plus 4 r square whole raised to 3 by 2. And how did this r cube become r square? Because there was one r remaining, right? So r square and 1 by 12. And in the second term what happens is, once we evaluate, we'll have to take the differential of r cube, that is nothing but 3r square. So the r square, the r term can get cancelled out, and we have to evaluate it once again. So first, while evaluating the integral of 1 plus 4 r square whole raised to 1 by 2, we get 1 plus 4 r square whole raised to 3 by 2. Again we have to take the integral for the second term in integration by parts. So it will become 1 plus 4 r square whole raised to 5 by 2 whole divided by 120. So and you have to substitute the value of r from 0 to 2, and the value substituted is given. So we can note that all these terms, there is no term of theta, so everything, this will be a constant. Okay, so you can take it out common, and what will be the integral d theta is nothing but theta, so it will be k into pi by 2 into the value is 5 into 17 raised to 3 by 2 by 12 minus 17 raised to 5 by 2 by 120 minus 3 by 40. You can just verify it. So I won't be explaining it again. This integration by parts will be much clearer if you do it on your own, if you just evaluate it on your own. And if you have any doubts, you can just inform me or let me know, and we shall find a solution for that. So this is how we can determine the mass of the particular surface, which is related to the surface integral. So that's it for today's lecture. Thank you. Stay home and stay safe.